Hello students. Today I'm going to go over chapter 6. Um, it is like introduction to chemical bonding. I thought it's a good idea to go over a little bit of the chapter. So if you see this chapter, we're going to talk about octet rule, electronegativity and polarity, drawing Lewis structures, formal charge, resonance, and exceptions for the octet rule. This is the basic introduction to bonding. So bonding is very important aspects in chemistry. So what is octet rule? Octet rule is all the elements in the periodic table they want to bond because they want to have 8 electrons in their valence shell. That's why like think about sodium. Sodium chloride. Sodium has 1 electron. Sodium loses that electron, becoming a previous noble gas configuration, and chlorine gain that electron. So always atoms will lose or share or gain electrons to have 8 electrons. So that's what I'm showing here. Fluorine F2 gain octet. And then Lewis structure. Lewis structure is another important aspect, that is a representation of covalent bonding. It shows Lewis structure shows only valence electrons. What are the valence electrons? Valence electrons in the outermost shell. Um, so it shows okay how these outermost shell bonding. So always when you draw a Lewis structure, you only draw the outermost shell. So if I show you, see, you can see. So in this mm, so oxygen has 6 valence electrons. Hydrogen has 1 valence electrons. How to draw a Lewis structure? So how to draw a Lewis structure? Very first thing in Lewis structure is, so we are drawing the Lewis structure for water. First thing, very first thing is you need to identify valence electrons. Valence electrons, then you need to identify the center atom. So how do you calculate the valence electrons for this water? So for the water, valence electrons, first, oxygen has 6. Oxygen has 6. How do I know oxygen has 6? Take a periodic table. Find the group number. Main group elements, group number equal to the valence electrons. What are the main group? In the periodic table, if you draw, like I'm just drawing the orbital structure, you have to, um, sorry, like that. Okay, like that. And then there is a transition metals, and then again, so this is the main group elements. Okay, so the main group elements, always keep in mind uh, group number equal to the valence electrons. So hydrogen has 1, so but you have 2 hydrogens, 1 into 2 plus 6, you have 8 valence electrons. Now you need to distribute these valence electrons among these atoms. The What is the idea of adding the center atom? Center atom always least electronegative element. Here, but this structure is different because hydrogen always go to the terminals. Center atom least electronegative, but at the same time hydrogen goes to the terminals. So here we write the center atom oxygen, hydrogen, hydrogen. And then we distribute these 8 valence electrons around these atoms. So let me distribute it. Let me make it a little bigger. Hmm, let's go. 1, 2, 3, 4, 5, 6, 7, 8. So this is how high water Lewis structure. And then if you draw this, each two uh, groups of electrons shows a one bond. So oxygen, hydrogen, hydrogen, one, two, okay. One, two, three, four. So this is the Lewis structure for, there's two more, okay. Lewis structure for water. And then you see there are two bonding pairs. These we call bonding pairs. Bonding. Okay, see, bonding. These we call, let me get another color so it's better. This is non-bonding, who we call lone pairs. So this is the basic, how do you draw a basic Lewis structure? Since I draw this Lewis structure, let me go to another one, a very common one, carbon dioxide. CO2. Let's do the same strategy. Lewis valence electrons, right? Carbon has four. Um, oxygen has six. So 4 plus oxygen, 6 plus 2, 6, sorry, 6 into 2. Multiply, okay, always, because it's 2. 6 into 2. So 6 into 2 is 12 plus, so it's 16 valence electrons. Now the center atom. Least electronegative atom, carbon is the least electronegative. C, O, O. You have 16 valence electrons. Always these atoms bond to make an 8 electrons out in the their valence shell. Always try to give the 8 electrons to the outer atom. So here you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now the 16 electrons gone. Now you look at the carbon. Carbon has 8 electrons? No, carbon does not have 8 electrons. Carbon has 1, 2, 3, 4. Carbon is not happy. How do you make carbon happy? You get electrons like that from each. So then carbon 1, 2, 3, 4. Oxygen 7, 8. 1, 2, 3, 4. Oxygen 5, 6, 7, 8. And then you get, so this you share 4 electrons. 4 electrons means double bond. Carbon, oh, oh. Let me take the things. There's no blue color maybe. 1, 2, 3, 4. 1, 2, 3, 4. So this is the Lewis structure for carbon dioxide. See, sorry, it's not showing there clearly. 4, 1, 2, 3, 4, 5, 6, 7, 8. Lewis structure for carbon dioxide. Okay. So that's how you draw Lewis structure. So you know now how to draw Lewis structures. Okay, let's go down. So we did the carbon dioxide. And then when you have the multiple bond, you call it triple bond. Always bond length stronger when you have the triple bond. Okay, so always okay. Now we are coming to another important aspect, which is electronegativity. Electronegativity is ability to attract electron towards themselves. So if you look at the periodic table, what do you think? Periodic electronegativity from I think about like left to right, metal to non-metals. From metal to non-metals, electronegativity increases. Metals has least electronegativity. They never attract electrons, they lose electrons. But if you think about non-metals like halides, oxygen, halide is group 7, oxygen, they gain electrons, right? They try to gain electrons. So always non-metals, so from going from left to right in the periodic table, electronegativity increases. So covalent, so there are like a covalent bond. Also, the depending on how electronegativity involved in the bonding, you can classify the covalent bond as pure covalent bond, polar covalent bond, and ionic bond. So let's think about it again. Right. So now I don't need this one. Um, so bonding, you can say ionic bonding, covalent. Covalent is sharing, right? And then this is also two types. Pure covalent, polar covalent. How do you divide into pure covalent and polar covalent? Depending on the electronegativity value of the two elements involved in the bonding. Okay. So if I go to the next one, so um, non-polar covalent is example a covalent bond, which that means sharing electrons between alike atoms, similar atoms. But if you think about non-polar covalent bond, when there is an electronegativity difference between the two elements involved in the covalent bonding. Ionic bonding, they're not sharing, they completely transfer electron. How do you know the electronegativity of these atoms? There's a periodic table. Periodic table with electronegativities. For this exam, you can have periodic table with electronegativities. You can type in the internet and see periodic table with electronegativities. At that time, you will see all the atoms, they listed the electronegativity. So this is like a sample table. You can look at it, you can use this for calculations, but for the exam, you need to print a new table. So that's why. So example, you see fluorine, F2. What is the electronegativity difference? FF. 4 minus 4, electronegativity difference is 0. But think about HF. 2.1, here you see 2.1 and 4. What is the electronegativity difference? 0.9. That means there's a electronegativity difference. So that is polar covalent bond. So this shows the how the each period how the electronegativity changes. Um, so you know there's like a little guideline. If the electronegativity between the bond involved in the bonding is less than zero point 0.5, it is non-polar, 0.5 to 2 polar, and then ionic. So if I ask in the exam, HF, what is the bond polar? Polar covalent? Yes, because you look at the electronegativity difference, which comes 0.9, means between 0.2 to 2.5 to 2, bond become polar covalent. Okay, so this dipole moment, partial charges, and percent ionic character. Dipole moment is this equation. Um, and then there are some worked example, you can look at it. But I'll, yeah, and then the percent ionic character is important. It is mu is, which is dipole moment observed. This is the equation. You can write all the equations in the sheet. So calculated mu calculated assuming discrete charges, that is the percent ionic character. I'm not asking you to find the percentage ionic character of anything, but you need to know the trends, like okay, this is the percent ionic character. So basically when you go towards the higher the electronegativity between two bonds involved, higher the percent ionic character. Okay. So drawing Lewis structures is another very important aspect. Another very important aspect. So you see, they draw the Lewis structure for ClO3. In ClO3, the draw the skeletal structure, the least electronegative element in the center. You see, oxygen electronegativity is 3 3.5. Cl electronegativity is 3. Least electronegative element is chlorine. Chlorine come to the center. And then you calculate the valence electrons. And then this we are drawing the Lewis structure for ClO3 minus. There's a negative charge. You add that There's a positive charge, you subtract. Negative means more electrons, you add that. So Cl, 1 Cl, 7, 3 chlorines, sorry, 3 oxygens, 1 electron, so 26. And then you distribute 26 valence electrons around these atoms by giving 8 electrons to the outer atoms, and then you look at the center atom, and then you draw the Lewis structure. Okay, so that is how you draw Lewis structures. It's very important you practice drawing Lewis structures. And also, let me take one Lewis structure with you, a little bit advanced Lewis structure. Let me draw the Lewis structure of SO4 2 minus. So now my least electronegative atom is sulfur, right? And then I need to get the valence electrons. I know sulfur has 6, oxygen has 6 into 4 plus 2. So you add that. So it's 6 into 4, 24, 24, 32. 32. And then my S, O, O, I add 2 because of this 2, okay? O, and then I gave 32 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 2. But I give the double one here, like that. You may wonder why, and then you write that. 1, 2, 2 electrons, like that, okay? So then you draw the, um, so you draw the, sorry, what happened? Something happened, sorry, just disappeared. Okay, so that's how you draw the Lewis structure. So a formal charge is another thing. Formal charge important to determine which Lewis structure is most stable. So example for my sulfate, when I draw, oh, yeah, it's here, okay. Let's see. Oh, that's good. So sulfate, I can draw two Lewis structures, okay. SO, SO, O, O, and then I can draw that same thing as this one. I can also draw this one, okay. S, sorry, O, 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 2, 3, 4. Okay, so these are the, this is kind of, okay, so this is the two Lewis structures for both compounds. And then formal charge shows which Lewis structure is more stable. For that, you have to find the formal charge for each and every atom. So how to find the formal charge? Number of bonding electrons minus, um, first you need valence electrons. So the formal charge is formal charge valence electrons minus, maybe they have valence electrons and associated electrons. Um, so so then here, so here you have, they have find the valence electrons. I want that. Okay, that's okay. So carbon, I really need that structure. Let me see. Mm, okay, that's okay. Oh yeah, this one I need. Okay, so for this one, formal charge, valence electrons, and bonding electrons, half bonding, non-bonding electrons, and half bonding, half non-bonding. So example, if I find a formal charge for this oxygen, valence electrons 6 because oxygen has 6 valence electrons, bonding electrons 2. This is 2, right? Bonding 2. Let me use another color, maybe red color, green color is good. Okay, 2, and then 6 minus 2 minus half non bonding electrons 2, non-bonding 6. So here, let me write the formal charge equation again clearly for you, then it's easy. Sorry. Formal charge, valence electrons minus bonding electrons, half, half bonding, and then non-bonding electrons. Formal charge is, you can see, oh my gosh, but where I'm writing not a good place, right? Because I need this slide, that's what I'm trying to keep it. It's okay. So the formal charge is valence electrons minus half bonding minus all non-bonding electrons. So 6 is valence electrons, half bonding, half into 2, and then non-bonding 6. So this formal charge becoming -1. Look at this oxygen, this one, okay. This oxygen formal charge is 2 minus here, 6 valence electron 6, half bonding, half 1. So it's same, right? Because it's the same and -1, all -1, all -1. And then sulfur, 6 valence electrons, all bonding, right? Half bonding, half into 6, half into 8. So like that, this all the atoms has formal charge. But if you look at this one, you know, this is -1. You can find -1, -1. But look at that one. 6 minus half into 4 into 4, 2, and then this is 0, and then sulfur, um, 6 minus half into 10, so it's a -1. So this one always has less. That's what I want to show you. The stable structure is when you can draw two more than one Lewis structure for same compound. More stable structure is structure with less formal charge. Okay, so similarly you can see how to find the formal charge on this particular compound. See, they found, okay, valence electrons associated, so valence electrons, shared electrons, they divide by 2. So like that they found, okay, uh, they find the electron associate with it. But you can always find the formal charge. Let me write the formal charge equation again so you know. Okay. Formal charge equals valence electrons, half bonding minus non-bonding. So this is the formal charge equation. And then you go to the, so that's how you do, that's the main ideas in this chapter. And hope this video will helpful for you to understand the main things we did, electronegativity and the Lewis structure. Thank you.